Hello, welcome again. We are solving some questions of applied mechanics. The topic is friction. Question number 9 and 10 carries a common statement. The statement is a uniform ladder 3 meter long weighs 200 Newton. It is placed against a wall making an angle 60 degree with the floor as shown in figure. The coefficient of friction between wall and ladder is 0.25 and that between floor and ladder is 0.35. The ladder in addition to its own weight has to support a man of 1000 Newton at its top at B. Then question number 9, the horizontal force P to be applied to the ladder at the floor level to prevent slipping. Option A 183.5 Newton, option B 371.5 Newton, option C 138.7 Newton, option D 385.4 Newton. Question number 10, if the force P is not applied but should be minimum inclination of a ladder with horizontal so that there is no slipping of it with the man at its top. Option A 63.5, option B 68.9, option C 73.1 and option D 72. So this is the ladder and here is there is man in first case, there is man of weighing weight 1000 Newton and the force of the and weight of a ladder will be acting at midpoint. Okay, so this is the man and this is the ladder weight and this is your 3 meter length and this angle is your 60 degree. Okay, so the force of friction between normal reaction between wall and ladder is RW and force of friction between wall and ladder is FW when it tries to slip downward. Okay, and force of friction between floor and ladder is FF and normal reaction is RF and P is the force applied on to prevent this slipping. Now considering the vertical forces, first of all considering horizontal forces are P, FF and RW. So from the horizontal balance we get P plus FF is equal to RW and from the vertical balance we get RF plus FW is equal to 1000 and 200. Okay, so that is 1200. Okay, now we have resolved vertical forces and horizontal forces. Now taking movement about A and to prevent any movement of the ladder, so the movement about point A should be 0. So movement about point A will be due to forces FW, RW, 1000 and 200. So the movement due to FW is FW into AC or we can say 3 cos 60 and due to RW will be RW into BC or 3 sin 60 and due to 200 it will be 200 1.5 cos 60. Okay, so and due to FW and due to RW it will be anti-clockwise and due to 1000 and 200 it will be clockwise. So equating these movements we have 200 into 1.5 cos 60 plus 1000 into 3 cos 60 is equal to FW is into 3 cos 60 plus RW into 3 sin 60. Now dividing by cos 60 we have plus 1000 plus is equal to 3 FW plus 3 RW tangent 60 and dividing by 3 we get this equation 1100 is equal to FW plus RW tangent 60. Okay, so now we can put the value of FW in terms of RW because this is force of friction and force of friction is given as coefficient of friction into normal reaction and normal reaction is RW, so it will be 0.25 RW. So if we put here FW is equal to 0.25 RW, we can get the value of RW. So RW will be with 555 Newton and if we know the value of RW then we can find out FW, so that is 0.25 RW, so that will be 138.7 Newton. Now we have FW, we have RW, so by the force balance equation we have FW. Okay, so from this we can find out RF and from the RF we have RW. Okay, from the RF we can find out FF. FF is your force of friction. Once we have found out RF, so after we have force of friction we have into RF. Okay, so now we have all the forces and the putting in equation number 1 the value of ff and rw, we can uh, we can find out force required to prevent slipping, that is 183.5 newton. Okay, so that is the force required to prevent slipping. Okay, now in the so answer to question number 9 is A. So the force required to prevent slipping is 183.5 newton. So in the second question, or in the 10th question number 10, it has been asked that uh, the force P is not applied. We have changed the angle of inclination, and angle of inclination is called alpha. Okay, and so that no force is needed to prevent it slipping. To prevent no force is needed uh, to prevent it slipping. Okay, so now again the here also, in this case also, the force of friction on wall and normal action on wall, and force of friction on uh, floor and normal action on floor, and weight of man and weight of pulley or weight of ladder is all are acting. Okay, so again doing the same way, balancing horizontal forces, so F will be equal to RW, and vertical forces RF plus FW will equal to 1200. Okay, so now we have two equations, and RW is equal to FF, and FF is equal to mu RF, and mu F is your 0.35. So RW and RF can be related by 0.35 into RF. Okay. Similarly, vertical forces will give RF plus the FW, that is 1200. Okay, and force of friction on wall is mu W into RW. Okay, so that is 0.25 into 0.35 RF. RW is 0.3 RF, or it is your 0.09 RF. So now we have FW in terms of RF, RW in terms of RF. Okay, and this equation has RF in terms of RF. So now we can put FW in terms of RF, that is 0.09 RF is equal to 1200 here. So from this we can get RF, that is 101 Newton. So once we know RF, so we can find out RW. Okay, and we can find out FW. So RW is your 385.4 Newton, and FW is your 99.1 Newton. So now applying the third equation is moment equation. So moment about A should also 0 in this case. Okay, to prevent slipping. So again moment will be caused by FW, RW 1000 and 200. Now the angle of inclination is alpha. Okay, so doing the same way we can form this moment equation. So that will be 1000 into 3 cos alpha plus 200 into 1.5 into cos alpha. Just the moment equation will be same, just we have to replace that angle 60 by alpha, FW into, and value of FW and RW in this case. Okay, FW into 3 cos alpha plus RW into 3 sin alpha. So okay, now we have value of FW, we have the value of RW. So we can put these values and find out alpha. So alpha will be a 68.9 degree. So answer is option B.